All right, hello again, team. We're looking at the next step here of building an intake arm for an XRP robot. We're going to have to start with a couple of modifications to our arm. We are going to add a motor to drive this. And for reference, here is an N20 motor, little gearbox. It's got an encoder on it, and some of the measurements I took off of the CAD for it. Those will be important soon. First, a couple of changes. Our coral arm, in order to have enough space to get these to spin correctly, meaning towards each other, we're going to close off the end. We don't need space for our game piece on either end, so we're going to close off the end and just kind of trim away the middle. This is kind of part of the process, is like changing your mind and updating your models afterwards, and waiting for Onshape to confirm with the server that I'm deleting these parts. There they go. Now, our motor, we just put in a hole for where this thing's going to live. It's going to be bigger than 0.157. I'm going to go quite a bit bigger, so like 0.17 or so. 1.7. So that's where the motor is going to poke through, but its position is dependent on how we're driving all of these. They need to move in towards each other and out away from each other. So the rotation from the motor will need to be inverted at a certain point. We're going to try to drive this whole thing with gears. So I'm going to draw in a few gears, and your construction lines are designed to guide your measurements, guide your decision making. So I put in a couple of gears. I put their pitch diameters. I've decided it's 0.4, and then we're going to need this gear to drive, or the motor to drive this gear directly. Let's make it 0.6 or so. So these pitch diameters will be tangential. I did not want you to move. I wanted you to move. What happened there? You move. This is for some reason bound to something. I don't know. Sometimes it's easier just to start over. You move down here. Thank you. All right. So that'll drive directly, but we need to sneak in another inversion kind of gear over here. Another circle. Again, this is the pitch diameter for it. Again, I'm just choosing 0.6 because I think it'll fit, and tangent to that. So we'll have this motor driving one gear directly, another one driving through this inverter, so that motion will be towards or away. A little bit wacky, a little tricky, but we're going to try and make that work. The next move, we're going to build out our motor mount. If we look at our reference, we have two holes for the motor mount. They're 0.07 inches. And these will just be driven through with the screws. There are, I think they're M1.7 or something. And for our purposes, we'll just make them all horizontal to each other. And the distance between them is 0.357. For our sake, I could have mirrored this, but 0.357, 0.05, 0.357 over 2, just to get that half distance between 0.357 over 2. So there's our motor mount. The motor's going to stick through. It's going to drive a gear that'll be attached to it, which will drive another gear and drive another gear, and then we'll have the motion we want. Next, let's make some gears. I am using a feature script called Spur Gear. If you don't know how to do that, add them down there. Add custom features. Again, the one that we're using is Spur Gear. So the depth here, 0.2 seems fine. Let's go down to pitch diameter, and 0.6 is our gear. I'm not going to change anything else about this. Let's just see how it turns out. And where, oh, there it is. There's our gear. We're gonna have to do some stuff to this, but the first thing I'm gonna do is translate it into position. Translate by mate connector, transform you from middle of that over to middle of that. Oop, there it is. Fantastic. There is a gear. I think it looks okay for now. They'll want a second one over here, right? That'll drive and we can, but I'm not too worried about making it here, about putting it in the part studio, because we're just gonna, print two of these. But we do need our second spur gear for the other two. So let's make that. And the pitch diameter for that one was 0.4. Again, I just picked those diameters, and let's make them like a little fewer teeth. I don't know if it'll get too crowded, but we'll see. Again, we'll transform this one into position. This isn't like entirely important, but putting them in place allows us to visualize how these are all going to work together. And then that's going to go to here. And I definitely screwed something up because that's not the right size. Those should be meshed. And I think I am going to have to fiddle with it. You can see these gears are not the right size either. They will not mesh. Let's take a peek at pitch diameter. Should have been 0.4. What happened? But there it is. Now, these aren't the same size. I'm probably going to have to adjust the teeth a little bit more. I don't know if it's directly proportional. So, for example, I went from 0.6 to 0.4. Let's just do a little bit of quick math. 0.4 over 6. 0.4 over 6. It's 2/3. So 24. I think we're 24 times 2 divided by 3. 16. Okay, we're off a bit. So for this one, rather than saying we've got 18 teeth, let's try 16. I think that'll proportionally clearly did not work. I think it keeps changing our pitch diameter. Okay. All right, that's a little bit weird, but I think what we have now are two gears that will properly mesh with each other. Now we've got to poke some holes in them from the purposes of mounting. Interestingly, this one here is going to have to mount onto a hex, or not a hex shaft, but a spline on our motor. Let's change this to motor gear, and start with a circle. And this circle should be, right now we're looking at the end of the keyway here for this. I've got it marked out at 0.118. So let's go a little bit bigger than that, 0.12-ish. And in fact, just because I've printed one of these before and tried to get it to fit, let's go a little bit bigger. And then there'll be a line across for the actual keyway here. I think it's at 0.9, 0.09, sorry, ish. 0.091, and interestingly, the tolerance should be smaller to get it to fit. So I'm going to say like 0.08 or something like that, just to give it a little more space for that thing to fit through. There it is, and then we can poke a hole, extrude, remove. There it is. That should fit on the end of our motor. As far as this one goes, this is our driven gear. Not extrude. Let's do a sketch. Driven gear. We'll do just a circle. Pretty easy for this one. Circle. And circle. And for this one, I think we're just going to put like a M3 hole through it, 0.13 or so, or an M3 bolt through there. So I don't think we need a bearing. We'll see. sure that's centered. And then poke a hole through that one. Move. Bam, there it is. That, and again, this one will be copied over here. Just print two of them. This one will copy over here. I don't know if I'll just run a drill through that, because this one will just be held in with a bolt as well. But that is our setup for our gearing. And then what are we going to drive? The last thing I want to look at for this video is what to actually drive. And I'm even considering just adding something onto this gear, but we'll see. I'm intending to print those in TPU. So I want to do a new sketch and kind of replicate a compliant wheel, like you might get, like the green wheels that you see all over the place. This is going to be our compliant. I'm going to call it a roller because I'm just going to make one, like a big one. And of course, we already have our measurement for these. That's these circles here. It's a 1/2 inch diameter. And again, we're going to have these spin on an M3 screw, I think. But I want them to be compliant. So squishy. So yeah, printing them out of TPU is one thing. I want to put a pattern in this as well that will grip. I don't think the TPU at the scale will grip very well. So I'm going to make a grippy pattern to kind of follow here. Just make a circle of some kind, and then do a circular pattern. That you always got to go to the origin to find the center of your circular pattern, and then make a ton of them. This another hunting problem. Oh, there it is, way over here for some reason. Is how many of these do you want? 20, I don't know, like 20? Let's see. Seems pretty good. Comes to mind that this will likely kind of extend a little too far, right, when you're looking at our game piece. So maybe we'll make our original circle. We'll delete that. What I want to do is, in fact, this should be stuck on there, and then make this smaller. And I've over constrained it somehow. Not sure where. Somewhere it's, oh, I think it's attached to something. But anyway, that's the action that we're going to have. It's going to spin and grip and grab the thing in there. We may have to fiddle with the geometry of all of this at some point just to get it to work, but we have something we can work with. And yeah, let's extrude that. It's going to be an interesting game of clicking. We've all been here. Same kind of thing. We could have gone in and snipped this up a little bit, but we didn't. I'm going to pause. All right, we extruded it. I still think there's some work needs to be done here. One last thing I remembered I got to add is a hole for this inverted gear to go. There it is. Now we're going to take a peek over at our assembly real quick, just to kind of get an idea for how this all goes together. Assembly, get bot. There's our servo arm. We've got to add. Let's add our, where is our actual thing? It is servo mount. It's all in here. Probably name that better. But we need the arm. Don't worry about our second arm. We'll get around to that here. Part 7, which I forgot to name. And we need 2 gears. Gear, gear, and 2 more gears. Gear, gear. Let's go revolute. Just plop it right on the end of our servo. Something like that. There's where it'll go. That looks good. And it can do its thing. And then let's do, oh, you know what we need too is a motor. There it is. Let's get that, bring that to the party. That'll go, and this doesn't have the mounting holes. The real one does, I promise. For this, I'm going to put it on the inside just to have, I don't know, protection or whatever. And then let's get our driving gear, if you will. Something like that. First driven gear goes like that. And where these get driven, you know, we may have to change this too. Because normally you'd like throw this on a hex shaft and it would drive, like it would spin. I guess I missed the last one. But these all might go on the inside. In fact, this might just become one piece where the gear and the roller are one entire piece. We'll also probably need some spacers, but again, the general mechanism concept is there. It is. And these can spin, right? Go up, spin, grab, go up, spit it out. We'll probably need something in the back to stop the game piece from just plopping out the back. And the motor probably help with that. So that's the end of this section. 15 minutes or so seems good. We're moving along. This whole thing's going to need a lot of refinement towards the end, but progress.